Alright class, here is our second video on forces in 2D. So the last one was, we kind of simplified it way down so you guys can kind of understand while I'm not there how to find components and use that to find acceleration and such. But the second scenario is this, where all of the forces cancel out. Okay. Now we talked about just as we were learning about forces, that when the net force, drew that weird, is 0, that means one of two things. Well, it means a few things, but it either means that we are at rest, the object that in question is either at rest or moving with a constant velocity, right? Okay, now that is a state we call equilibrium. Can't write today. Okay, and that's a word you've probably heard before, but it means, equal. It means balanced, and that's what it is. When we have balanced forces, you can say that an object is in a state of equilibrium. And so we're going to talk about some problems where we have an object that's in equilibrium. So, just as how you can recognize that when net force is 0, you know that either means the object is at rest or moving with a constant velocity, we can do the reverse. We can say that if we see an object is at rest, that automatically means this, or the same for a constant velocity. So objects that are in equilibrium and meet this category, that are rest, they're not moving, meaning that they are static. So we can kind of refer to this section as statics, meaning the study of forces of things that aren't moving, right? So the easiest example that we talk about here is with a couple different situations with signs, like signs that are hanging from a cable or a string or something like that. So the first one, let's say you have a sign here. And there are exactly two types of problems that I'm going to want you guys to know how to do. So say you have a sign here, hanging, and we'll give it a nice easy mass of 10 kilograms. And it's suspended by two strings. Okay, so imagine that there's like some building here. It's kind of hanging in the corner of this building. And so let's say there's a little hook here, and you have a force like that, or a string like that, and a string like that. This string is horizontal, this is at some angle, we'll call that 40 degrees. Okay, sorry if you can't see it, but that says 40 there. So let's think about all the forces acting on our little sign. So the first force we can recognize is, of course, the force of gravity. That's always there. That acts in the downward direction. That's the force of gravity. As we know, that is always equal to m times g. Now, to balance that, there must be some force going upwards. And that's kind of where our whole philosophy kind of comes in. Because a question like this would ask you to solve for the tension in this string and the tension in this string. Now remember what tension is. That's just a fancy word for force, like in a string or wire or cable of some kind. So we're just solving for two missing forces. So I'll show you how to set up with the equation, but I first want to kind of explain to you like the philosophy of all of that. And so we have gravity going downward. That first and foremost needs to be balanced out. Now, a vertical force, a vertical down force, can only be balanced out by, make this a little closer here, a vertical upwards force. Sorry about that. Now, this one cable here, that's horizontal. A horizontal cable cannot apply a vertical force. It can only apply horizontal forces. So that force is acting in this direction. This force is acting in that direction. So, seems like because this has no capability to apply a vertical force to this, that this is fully balanced out by the vertical component of this cable. You can call that T1Y if you want. T1Y. And T1 also has cable 1 here, also has an X component. Call that T1X. So now we have identified all of the forces by components. You have T1X, T1Y, one horizontal, one vertical. You have T2. T2 is an X component, has no Y component. And you have this. So, the way to think of this, without really setting up an equation yet, is that we know how much this is equal to. That's equal to 98 newtons, right? You can call it negative if you want to because it's going downward. That has to be balanced by this one going upwards, which means that it also has to be 98 newtons. Now that I know one side of this triangle, I can figure out the other two sides of this triangle. Okay, but let's first put this into an equation. Okay, I know trig bothers you guys sometimes, and this picture isn't super great right now. So let's just think about it this way. There is no acceleration in either dimension. So we can say the net force in the x is equal to 0, and the net force in the y is equal to 0. In the y, we have two forces. You have the force of gravity, and you have the vertical component of cable 1. You already told me, if you were here, that the force of gravity, via this equation, is 98 newtons, going downwards. The only way that two things can add up to 0 is if they are equal and opposite to each other. So that means that we know what T1Y is. So T1Y is equal to 98 newtons. And let's just write that in up here, 98 newtons. And if you're a savvy trigonometry person, you can right off the bat figure out what T1 is. But you know that this is the y component, and you know that y component. So to do that right now, the y component of T1 would be equal to T1 sine of theta. That's just from trigonometry, and that's just an equation. That a y component of a force is equal to that force times sine of an angle. So now we're kind of doing it backwards. We have y component, we have the angle. Let's solve that for T1. So we'll rewrite this with the angle put in. The angle, I know it's hard to see there, is 40 degrees. So solving this for T1, we just get 98 newtons divided by sine of 40. Plug that into our calculators, and we have half of our final answer. 98 sine 40. That gives us 63 newtons. So we know what that is. But let's go back up to this, because we still figure out what T2 is. Now, just like y dimension, we have two different forces that add up to 0 in the horizontal direction. T1x and T2. So you can say T1x plus T2 add up to 0. Let's rewrite that down here. So we have some area. Change colors. The net force in the x 0. T1x plus T2.
So, you know what T1x is? We have the hypotenuse, we have the angle, so it seems to me that we should be able to figure out T1x fairly easily. As we always do for x components of a vector, just equal to that vector times cosine of the angle. It'd make the horizontal. We have T1 now, we have the angle, and then we're going to solve all that T2. Plugging in numbers now, T1 we already said 63. Cosine of 40 plus T2. So that means that 2 is equal to negative, you make this negative since it's going west, so the T2 positive, 60 cosine of 8. In other words, this is equal and opposite this. And I know you guys might help on the fact, well, the one triangle, the length of